All right, friends, I'm going to do these last two questions from our Circles and Tangents guided notes. So number 8, we're just deciding whether these statements are sometimes, always, or never true. A chord is a diameter. Let's think about what that looks like. Oh, that's a terrible circle. Okay, so let's say we have a circle and here's a chord. Is it also a diameter? And the answer is it could be, but it doesn't have to be. So this diameter is definitely a chord, but this chord is not also a diameter. So I guess the answer to that would be sometimes, because it can be a diameter, but it doesn't have to be. However, if we already have a diameter is always a chord. That's because if we look at this diameter, it's always a chord. It's just a chord that happens to go through the center of the circle. Here it says a minor arc has a measure of 193 degrees. We learned that minor arcs are always less than 180 degrees, so that's going to be a never situation. That would be considered a major arc. And then last, it says the measure of a central angle is the measure of its intercepted arc. This is, we sort of use this term corresponding in addition to intercepted, so those terms are really the same. And what that would mean is if I were to draw an arc in here, let's say this is 65 degrees, draw a central angle, does that mean that its intercepted arc is also 65 degrees? And the answer is yes, that's always the case. We're gonna hop right down here again. This one gives us a diagram and we're asked to find a lot of lengths. And the way this one works out is it actually makes sense to just start and go down the list, and they increase in difficulty. So it says, given that DC and BC are tangent to circle A, that means that they form right angles with the radius at the points of tangency. So we need to find each of the following. So BC is this segment here. Because these are both tangent lines, these line segments here at the point of tangency and this exterior point, those are going to be congruent. So they're both going to be 15. The measure of BCD, well, BCD, that angle here, we can find, this is similar to a problem we did earlier, if the sum of these is 180, then the sum of these is also 180. So I can simply subtract 124 from 180, and that's going to give me 56 degrees. So this acute angle right there is 56 degrees. And again, it's because these add up to 180, these add up to 180. The measure of angle ABC, we already know that one, that's 90 degrees. Because it's where a tangent line and a radius meet at the point of tangency. The last one we need to find is the length of segment AD, and that's a little trickier. So that's this guy here. And how we're going to do that is we're going to think about the fact that this is a right triangle, okay? And we learned that because these two triangles are congruent by well, we could do side, 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 side angle, side, hypotenuse, leg, all sorts of different theorems, but that all their parts are congruent as well. So this line is an angle bisector. That makes each of these angles 62 degrees. And what I can do is I can redraw this right triangle, sort of like this. There's my right angle. Here's my 62 degrees, and here's my long leg, that's 15. And I can use trigonometry to find this sort of apparent short leg here. That's the one I'm looking for. I'm going to call it X. So I'm going to use tangent here and say that tangent of 62 degrees equals opposite over hypotenuse. Sorry, opposite over adjacent. If I cross multiply here and I isolate for X, I'm going to get that X is 15 divided by tangent of 62 degrees.